So this is lesson number 33 in Algebra 1, products of prime factors, statements about unequal quantities. All right, just to remind you that we have what are called composite numbers. Okay, this is an M. And we also have prime numbers. Composite numbers are numbers that lots of numbers divide into, like 8. You can divide 2 into it, 4, 8, and 1. So those are composite numbers. A prime number, you can only divide 1 into itself. So 1 and 7 go into 7, but that's it. So they're called prime numbers. So that's what we're going to look at. We're going to look at what are called product of prime numbers. Product, if you remember, means that it's an answer to a multiplication problem. And what we're going to do is we're going to take a number that is a composite number and break it down into its product of primes, which means if we have a number like 12, it's composite, and we're going to break it down into factors that are just prime. So for example, what goes into 12? Well, 6 and 2. And then you look and say, oh, well, 2 is a prime number. I'm going to circle that. But 6 isn't, so we're going to keep going until we have prime numbers. What are the two numbers that multiply together to give me 6? 3 and 2. Well, I know that 2 is prime, and I know that 3 is prime. Nothing goes into 3 or 2. So my product of primes are the numbers that I have circled. Product, multiplication. If I take 2 times 2 is 4, times 3 is, I get 12. So the product of primes are what are all of the prime numbers multiplied together that give us the 12 there. And we use what I just used there as a factor tree, and we'll keep practicing some of those. Let's use example 1, and let's use 80. So again, we make that, and I know 80 is even, so I know 2 goes into it 40 times, and 2 is prime, so I circle it. 40 is an even number, so I know 2 goes into it 20 times, so I circled that because that's prime, and I'm done. And 2 goes into 20, and 2 goes into 10, and 5 is also prime. So my product of primes for 80 is 2 times 2 times 2 times 2 times 5. That means if I multiply all those numbers together, I'm going to get 80. All right, let's look at the next one here, example number 2. And it gives us kind of a funny number there. It gives us 147. And we break that down. All right, so what goes into 147? Well, if we take 1 plus 4 plus 7, which are those three numbers, and we get 7, 8, we get 12. Well, does 3 go into 12? Yes. Then 3 also goes into 147. So that's kind of a handy trick to try. So I know 3 goes into it, but how many times does 3 go into it? 49. And 3 is prime. 49 is not prime because 7 times 7 is 49, but 7s are prime. So the product of primes for 147 is 3 times 7 times 7. So 3 times 7 is 21. 21 times 7 equals 147. So I know that's right. 3 times 7 times 7. And that's what the product of primes is. That's what you're going to be doing in that part of the lesson. Now let's look at the second part of this, statements about unequal quantities. All right, statements about unequal quantities. We're going to do some more story problems, and they start getting a little bit more challenging. So, look at 33.3, example 3 there. Twice a number is 42 less than negative 102. So what did I say? I said if I take this and multiply it by 2, okay, twice a number, this answer is going to be 42 less than that answer. But I put an equal sign there. If I put an equal sign, that means they're equal. What did I say? This is 42 less. So how would I make it equal to that? Well, I would make it I would add that 42 that it's less than. Okay? Because this is 42 less than that, and I want them to be equal. So if it's 42 less, I'm going to add 42, and now they're equal. And now I do the math. So I subtract 42 here, subtract 42 here, and I get 2n equals 102 minus 42, and that's going to give me negative 144. Divide by 2, divide by 2, n equals negative 72 for an answer. And then I can take this and plug it in. Whoops, I don't want to plug it in there. I want to plug it in there because this is the beginning of my story problem. Okay, let's look at the next one here. Example 4 there. It says that 5 times a number is 72 greater than the opposite of a number. Are they equal? No. This number here is 72 greater. In order to make it equal, I have to subtract that 72. I need to take that 72 that makes it greater. I need to take it away. So it's no longer greater, it's equal to. So now I can take negative 70. Well, let's do it this way. I'm going to rewrite it in yellow here. 5n minus 72 equals negative n. Okay, so I am going to take away 5n here, take away 5n here. Those go away. Negative 72 equals negative 6n. Then I'm going to divide by negative 6, divide by negative 6. Those cancel. A negative divided by a negative is a positive, right? 72 divided by 6 is 12, and that's the number. So if we put a 12 in here, multiplied it by 5, we'd get 60. And if we subtract 72, we'd get negative 12. And we just said that n is 12, so opposite of 12 would be negative. So yes, that would end up working. Alright, let's look at another example. Example 5. If we have the sum of twice a number and negative 14. So we've got the sum of twice a number, and it says sum, so we have a plus. Plus what? Negative 14. Put that in parentheses or you might make a mistake there. And we multiply that whole thing, it says, by 2. So see how we just kind of stack things up. Twice a number and negative 14 is multiplied by 2, and the result is, now let's make that my equal sign over here a little bit. The result is 12 greater than the opposite of the number. Well, our opposite of the number is there. Are they equal? No. This answer here is 12 bigger than this. So in order to make it equal, I need to take that 12 away from there. Now I can start solving this problem here. Okay, let's go ahead and do this. 2 times 2x plus negative 14. Okay, so far I haven't really done anything. Minus 12 equals negative x. Okay, I thought maybe I could do something in the parentheses. I can't. Alright, so let's go ahead and distribute. 4x minus 28, because 2 times negative 14 is negative 28. Now we have minus 12 equals negative x. So let's see what we can do. Negative 28 minus 12 is the same as plus negative 12. So the signs are the same, so we add them together, and we take the sign and put it on there. So 28, 38, 40. Okay, we're going to subtract 4x from both sides to get rid of that, so we just have the negative 40 there. Divide by negative 5. Divide by negative 5. 40 over 5 is 8. Two negatives give you a positive, and that gives me my x value of 8. And I go ahead and plug that in, and I'll get the right answer. Last one. Example number 6. 5 times a number is 21 less than twice the opposite of the number. There's twice the opposite. Are they equal? No, they're not equal. The one on the left is 21 less. So in order to make it the same, I'm going to add 21. And now they're equal. And then I do my math. 5x plus 21 equals negative 2x. So let's subtract 5x from both sides to get rid of that. Divide by negative 7. Get rid of that. 21 over negative 7, a positive over a negative is a negative. So I get x equals negative 3. And when I plug this negative 3 in here, and here, and this is what happens here. This is 2 times negative, and what is x? Negative 3. So I get 2 times positive 3, because these two are going to be positive. Okay? And they should all check out and be just fine. So that's it for lesson number 33.